Determine the sum to n terms of the following series. Let us begin. So here we have a series. This is a special type of series with the first term being 3 multiplied to 8 added to 6 multiplied to 11 and the third term being 9 multiplied to 14. And we have the rest of the term. Now to find out the sum, we first need to figure out what is the nth term of the following sequence. To find out the nth term, we'll suppose that let Tn represent the nth term of the above series. So here what we'll do, let's consider the first digit of each of the term. So we have 3, 6, 9. Now clearly, this is an arithmetic progression. The terms are going to be in AP. If the terms are in AP, then this is the first term A, the common difference D, this equals to 3. So we can define the nth term, which is A plus n minus 1 times the common difference D. So we have 3 added to n minus 1 times the common difference D. So this is going to give us 3n. So that's going to be the nth term of the sequence, which terms are 3, 6, 9 and so on. Next, if we consider the second digits of each of the terms, so we have 8, then we have 11, then we have 14. Now these terms are also going to be in arithmetic progression. So here also we have the first term, that's 8. The common difference D equals to 3. That means the nth term is going to be 8 added to n minus 1 times the common difference 3. So that's going to give us 3n. So we have 8 minus 3, so that's going to be positive 5. So that's going to be the nth term of the sequence, whose terms are 8, 11, 14. And we can now, using the nth term of these two sequences, we can define the nth term of the series. So we have the nth term of 3n, which is the nth term of the sequence, 3, 6, 9. But this will get multiplied to 3n plus 5. So this is going to be the nth term of the series. So let's simplify this. This is going to give us, so 3n times 3n, that's going to be 9n squared. Added to 3n times 5, that's going to be 15n. Okay, so now that we have the nth term, we are ready to find out the sum. The sum of the series, that's simply going to be given by summation tk. So here we are replacing the index n with k. So it's going to run from 1 to n. So this is going to be equals to find out the sum, now what we'll do, since Tn we have 9n squared plus 15n, we have to replace this n with the index k, such that we get 9k squared added to 15k. Fine. So we have the index k running from 1 to n. Now we will separate the two sums. So for the first sum, we have summation 9k squared, but 9 being a constant, we can pull it out of the summation. We have 9 times summation k squared, where k runs from 1 to n, added to 15 times summation k, where k runs from 1 to n. Okay, now we have a standard formula. Now summation k squared, that simply stands for the sum of the squares of the first positive n natural numbers. That means we have summation k squared, where k goes from 1 to n. This is simply 1 squared plus 2 squared plus 3 squared all the way up to n squared. And the formula that we obtained was n multiplied to n plus 1 times 2n plus 1 whole divided by 6. Similarly for summation k, where k goes from 1 to n, now this is the sum of the first n natural numbers. And the standard formula was n times n plus 1 whole divided by 2. So we're going to use these two formulas. So we have n multiplied to n plus 1 times 2n plus 1 whole divided by 6. That will get added to 15 multiplied to n times n plus 1 whole divided by 2. Okay, so we have 3 times 3, that's 9, and 3 times 2, that's equals to 6. Now what we can do, we can take 3, we can take n, and we can take n plus 1 as the common factor from both of the two terms. So that means this will get now multiplied to 2n plus 1 over 2, added to 5 over 2. So let's further simplify. Now we have 3n multiplied to n plus 1. Then here we have 2n plus 6 divided by 2. Or we can say 3n multiplied to n plus 1 multiplied to n plus 3. So this is going to be the total sum to n terms of the series 3 times 8 plus 6 times 11 plus 9 times 14 all the way up to n terms.